All right, today we're going to talk about graphing polynomials and listing out some key features. So the first new key feature that we're going to talk about is going to be called the in behavior. So if you look over here to the side, we have a little definition for that. And it says in behavior describes what happens to the function values, which when we say function values, we really mean what happens to the y numbers as x approaches positive infinity and negative infinity. Now, when I say x approaches positive infinity, I mean what happens on the right side of the graph. And when I say negative infinity, I mean what happens on the left side of the graph. Now, there is a specific way that we want you to write your answer for in behavior. Okay, so down here, I'll kind of jot that down. You're going to start by saying x or as x. And instead of writing the word approaches, we use a little arrow here, a little sideways arrow that stands for approaches. Positive infinity. F of x, which we're going to use f of x instead of the letter y, but function values, remember that's y, f of x is y. Approaches, and then your job is to fill in. Does it go up, which would be positive infinity, or does it go down, which would be negative infinity? The second one, you're going to start with as x approaches negative infinity, then f of x, the y numbers, what do they approach? Do they approach positive infinity or negative infinity? Now, if you don't have a graphing calculator to graph it and you're only looking at the equation, we do have a chart here that you can use. But if you have a graphing calculator available, then you can graph it and look at it. But let's kind of talk about the chart. On the chart, okay, if we look up at the top, it talks about an odd degree. Okay, what you need to know is that degree, when we say that in math, that stands for the highest exponent in the problem. Okay, apparently my handwriting was not very good right there, so let me retry that for you. But it stands for the highest exponent. And of course, if it's odd, then odd is saying like it's a power of 1, power of 3, power of 5. Or over here it says even, which would be power of 2, 4, 6. Okay, so once you know degree, then you get to come over here to the side and you get to look at the leading coefficient. Okay, and then you're trying to decide if the leading coefficient is a positive or a negative. And then once we know that, then you can decide which one of the 4 boxes to look at. And so we can actually do that in a problem later, but I just kind of wanted you to know degree was the highest exponent. You have to decide if it's even or odd. And then leading coefficient, you have to decide if it's positive or negative. The other thing, when we get down here to the next example, that we're going to add in that we've talked about in a different unit is, of course, y-intercept. So first, let's just talk about in behavior. I'm giving you a picture of the graph, and I want you to tell me the in behavior. And if you notice, I was nice enough to type out all of the in behavior except for the part you have to fill in. So on the first one, it says, as x approaches positive infinity. So positive infinity means right side. So if I'm looking on the right side of my graph, what are the y numbers doing? So when you look on the right side, does everybody agree that this graph is ending pointing downwards? And if it's pointing downwards, so that means the y numbers are going on negatives forever and ever and ever. So you would put negative infinity. And then the middle one here, it says as x approaches negative infinity. Well, that means left side. So if you look at your picture on the left side, you're going to notice that, oh, this one is pointing up. It's going up forever and ever. So here you would put positive infinity. So remember, your choices for end behavior is either positive infinity or negative infinity. Okay, y-intercept. Remember, y-intercept is where it crosses the y-axis. And if I look at this problem, it crosses my y-axis right here, and that is at -2. So y-intercept is always 0, and then where it crosses the axis, so 0, -2. Okay, if we go across to the next one. Remember, positive infinity means look on the right side. And if you're looking at the right side, you're going to notice that this one has an arrow pointing up. So that would be positive infinity. As x approaches negative infinity means left side. And if you look at the left side, you notice it also has an arrow pointing up. So that's positive infinity again. And then the y-intercept is where it crosses the y-axis. So it looks like it crosses my y-axis right here in between 6 and 8. So I'm going to call that 7. So 0, 7. Or if you said like 7.5, that's fine. It is a little hard to read. But as long as you have something more than 6 and less than 8, then you're okay. All right. Now we're going to go to ones where you don't have the picture, okay? And instead I give you the function. And I'm also going to make you go back and do roots that we talked about in a previous lesson. I remember roots are also called zeros. So the first thing I would want you to do is I want you to go, let's say we're going to use a chart this time for end behavior. I can kind of show you both. But if we were looking at the chart, the first thing I need to look at in this equation is what is the degree? What's the highest exponent? So here I'm going to say the degree is 3. That's my highest exponent. And then leading coefficient. So I'm going to call that LC for leading coefficient. So leading coefficient, what would be the number in front of x to the third? Well, that would be a 1. And that is a positive number. So I want to look for degree of 3, which is an odd number. So 3 is odd. And leading coefficient is 1, which is positive. So if I come up here and I want to look in the category where it says odd. So we're right here where it says odd. And then we said the leading coefficient is positive. So then these two things right here give me my answer. So if you look here, it says as x approaches positive infinity, that f of x approaches positive infinity as well. So I'm going to scroll down here, and I'm going to do positive infinity. Then I'll scroll back here, and it says as x approaches negative infinity, well, f of x also approaches negative infinity. So that's how you do it with the chart. Now, if you don't have a chart, let's say you're going to use a graphing calculator. So I'm going to pull up my app for the graphing calculator. And remember, to graph, you're going to go to the y equals key. Clear out anything that happens to be there. And then we're going to go x to the third power minus 5x to the second power plus 2x plus 8. And then I'm going to hit graph. Now, sometimes you can't tell on your window and you might have to adjust your window, but this problem, I can easily see that on the left side, it is pointing down. And I can see on the right side that it is pointing up. So you could also come over here and get your answers for the end behavior by looking at that. Okay. So you could also get these right here. So now let's go with y-intercept. So for the y-intercept, I'm going to go to the t-table. So hit second graph. And remember, you go to where there is a 0 on the x column. So right here. And you're going to say the y-intercept is 0, 8. So then I'm going to go back, and over here I'm going to do 0, 8. Okay, now the zeros. Go back to my graphing calculator. And remember, to find the zeros or the roots, you look for 0 in the y column. And remember, the highest exponent tells you how many you have to have all together. And my highest exponent or degree in the problem is 3. So you'll notice I have a 0 at -1, I have a 0 at 2, and I have a 0 at 4. And I don't care what order you write them in, but we had one at -1, 2, and 4. My highest exponent is 3, so I actually got to see all 3 of them on the calculator. Yay, I don't have to do synthetic division on this problem. And this problem means we will in the future. So now all I have to do is come down here and sketch the graph. Okay, when you are sketching the graph, I would like you to plot the zeros. So any of the real zeros, please plot them, which ours are all real, so I get to plot them. Okay, and then once you have that, we can kind of draw in the rest of it. Okay, so remember, on your picture, on the left side, the graph has to be going down. So you know you're going down on the left. On the right side, we said the graph was going up. And then I'm just going to make it follow the picture that was on my calculator. So I'm going to do this, come through here, and then go up, out that way. And then I have my sketch of the picture. Okay. All right. So now let's go to here. So instead of scrolling for the chart, I mean, if you want to use a chart, you can, but instead of scrolling for the chart, I'm just going to go to the graphing calculator. I'm going to go back to y equals. I'm going to clear this out, and I'm just going to type it in and look at the picture on this one. So I got negative x to the 4th power plus 6x to the 3rd power minus 13x squared plus 24x minus 36. So I'm going to hit graph. Okay, on this one, I know it looks like all I can see here is a little U shape. I'm going to try changing my window just to see if there's any other curves or humps or anything. So I'm going to go to my window key, and let's look down a little farther. So instead of -10, I'm just going to kind of over exaggerate here, and let's do like -50 and see if the graph curves back up at all or not. And to me, it doesn't look like the graph is curving back up. So to me, it looks like there's going to be some imaginary zeros. And how do we know there's imaginary zeros? Well, what's the highest exponent in the problem? The highest exponent is 4. Okay, so that means I'm going to have 4 zeros, but I only have one that I can see on the graph. Oops, sorry. My pen wasn't working for a second there, but now I got it working. So if I go back to my graph, the only 0 I see, so second table, 0 in the y column, the only one I see is at +3. And then when you look back at the picture, does everybody notice that at +3 right here, it looks like the shape comes up, it touches it, and then bounces. It doesn't actually go through it. It touches it and bounces and goes back down. And if you remember what we call a bounce was when we said it had a multiplicity. So we would say 3 multiplicity of 2, because that means 3 counts twice. So right now I have 2 of my 4 answers for zeros. So to help me find the other ones, I'm going to have to go use synthetic division. So I'm going to put 3 in my corner box, list out my coefficients, -1, 6, -13, 24, -36. Remember, drop the first term and then multiply, add. Multiply, add is your pattern that you're going to do. And of course, remember the remainder should always be 0. Now I'm going to do synthetic division again with 3, because remember we said multiplicity of 2, which means 3 counts twice. So drop, and then the pattern is multiply and add. And you better get a remainder of 0. So now in the original problem, the highest exponent was 4. So the first time I divide, that will drop to x to the third. The second time will drop to x squared. And then regular x, plain number, and no remainder. So I'm looking at negative x squared minus 4 equals 0, because I want to solve it. Okay, so you always take what you have and set it equal to 0. Here I'm going to add the 4 over. So plus 4, plus 4. So negative x squared equals 4. Then I'm going to have to divide by -1. So x squared equals -4. Then to get from x squared down to x, I'm going to square root both sides. Remember, when you do a square root, you're going to have plus or minus. The square root of 4 is 2, and because there is a negative, you have to remember to put an I. And the plus or minus means it counts as 2 answers. So there's my 2 imaginary zeros that you could not see on the calculator, which makes a total of 4 zeros. Okay, in behavior. So if I go back to my picture, you should be looking on the left side, saying it's going down. Looking on the right side, saying it's also going down. So then you would have negative infinity on both of them. Okay, y-intercept, go back to the t-table, find 0 on the x, and the y number is -36. So you have 0, -36. And then the last thing we want to do is we want to sketch the picture. Okay, remember you must plot the zeros. So my 0 is at 3. I can't plot the imaginary ones because they don't exist on the real plane. So that's the only thing I plot. Now I just kind of go back to my graphing calculator and I want to sketch a graph that looks something like this one. So it's just going to kind of go in like this and bounce back down. And there's my sketch. Okay. You should pause the video and try the last one by yourself and see how far you get. Okay, I will slowly start to write some stuff down, but I'm not going to say very much until the end. Ooh. I am going to have to change the window. So remember, I'm going to do zoom 6 for the normal window. Okay, now I really can't tell where these are connected, so I am going to have to change the window. So I'm going to change both the y numbers. Over exaggerate. Okay, so to me, it looks like on the left side, the graph is going up because I can see that it's going to connect down here. And on the right side, it looks like the graph is going down. So for end behavior on the right side, I'm going to say down. And on the left side, I'm going to say up. Okay. Table. Y-intercept would be at 0, 32. Zeros in the other column, it looks like I have -4, 2, and +4. So -4, 2, and +4. But the highest exponent is 5, so that means there's 2 of them that are not available right now. And the reason they're not available is if I go back and look at the graph, you're going to notice that it's going to cross at some decimals here and here. So let's go do some work to figure those decimals out because we can't just guess. So I have to do synthetic division 3 times with the non-decimal ones. And hopefully you're remembering the pattern of multiply, add, etc. And you should get the remainder of 0. Then do synthetic division the next time. Oh, whoops, don't forget your negative. And get the remainder of 0. Then we have to do synthetic division one more time. And I get a remainder of 0. And now, remember we started with x to the 5th. That's x to the 4th. That's x to the 3rd. And then we're down to x squared, x, plain number, and constant. Okay. And then from here, I would use the quadratic formula. So remember the quadratic formula starts out with -b. So that would be -2 plus or minus square root of b squared. So 2 squared minus 4 times a times c all over 2 times a. Work out the part underneath the square root. Oop. Get to bring in lots of stuff from last chapter again. Factor tree. Oop. Then I get to reduce. So then I get to come back up here and say it's 1 plus or minus the square root of 2. But now for me to actually be able to graph these, I'm going to go ahead and work this out on my calculator and get a decimal. So if I type that in my calculator, I get about 2.4. If I type this one in my calculator, I get about negative 0.4. So you could also kind of check yourself and make sure that those match the decimal ones that you see. So now we get to make a sketch. My zeros were at -4, +2, and +4. And then my decimal ones were at 2.4 and about -0.4. And I know on the right side, we said it was going to go down. And on the left side, we said it was going to go up. There's no multiplicities, so you know it's going to go straight through. So we're just going to sketch our graph that looks something like what it does on the calculator. And you're done. That's it.